Which of the following techniques is used to evaluate the performance of a machine learning model? Using scikit-learn's model selection module. A. Train test split. B. Cross-validation. C. Hyperparameter tuning. D. All of the above. 1. Train test split. This method divides the dataset into two parts: training data used to train a model and testing data used to evaluate the trained model's performance. Correct. Train test split is indeed used to evaluate model performance by training on a portion of the data and assessing the trained model on unseen data. It's a basic technique in scikit-learn's model selection module. 2. Cross-validation. This technique involves dividing the data into multiple fold subsets. The model is trained on a portion of the data, all but one fold, and evaluated on the held-out fold. This process is repeated for each fold, and the average performance across all folds is calculated. Correct. Cross-validation is a more robust evaluation technique than train test split. It provides a more reliable estimate of the model's performance by training and evaluating on different subsets of the data. It's also a key component of scikit-learn's model selection module. 3. Hyperparameter tuning. This involves finding the best set of hyperparameters for a machine learning model. Hyperparameters are settings that are not learned from the data during training, e.g. the number of trees in a random forest. Methods like grid search CV and randomized search CV systematically explore different hyperparameter combinations to find the optimal configuration. Correct. Hyperparameter tuning is indirectly related to evaluation. It involves searching for optimal model parameters to achieve the best performance. Grid search CV and randomized search CV in scikit-learn's model selection module are crucial for this process, allowing us to find the best settings for a model. Therefore, all of the above techniques are used for evaluating and tuning models within scikit-learn's model selection module. Correct. All the techniques train test split, cross-validation, and hyperparameter tuning are integral to model evaluation and tuning in scikit-learn's model selection module. They work together to ensure a robust and efficient model development process. D. All of the above. A technique for assessing a model's performance by dividing the data into multiple fold subsets. The model is trained on all but one fold and evaluated on the held-out fold. This is repeated for each fold, and the average performance across all folds is calculated. Evaluating the performance of a spam filter for emails. Assessing the accuracy of a medical diagnosis model. Let's say you have a dataset of 1000 images for classifying cats and dogs. You can use 5-fold cross-validation to evaluate a model's performance. You divide the data into 5 folds, 200 images each. For each fold, you train the model on 80 of the data 4 folds, 800 images, and test it on the remaining 21 fold, 200 images. You repeat this for all 5 folds and calculate the average accuracy. A simple technique for evaluating a model's performance. The data is divided into two parts: training data used to train the model and testing data used to evaluate the trained model's performance. Evaluating the performance of a recommendation system for movies. Assessing the accuracy of a fraud detection model. Assume you have a dataset of 100 customers' spending habits. You can split it into 70 training data 70 customers and 30 testing data 30 customers. You train the model on the training data and then evaluate its performance on the unseen testing data. The process of finding the optimal set of hyperparameters for a machine learning model. Hyperparameters are settings that are not learned from the data during training. They determine the model's structure and behavior. Optimizing the number of trees in a random forest for image classification. Finding the best learning rate for a neural network for natural language processing. Consider a support vector machine model with a hyperparameter C that controls the trade-off between achieving a low training error and maximizing the margin. You can use grid search CV to search for the best C value within a range e.g. 0.1, 1, 10. The model is trained and evaluated for each C value, and the best performing value is selected. A technique in scikit-learn's model selection module that systematically explores different hyperparameter combinations for a model. It trains the model on all possible combinations of hyperparameters and evaluates its performance on a separate validation set. Finding the optimal hyperparameters for a logistic regression model for predicting customer churn. Tuning the hyperparameters of a k-nearest neighbors model for image classification. Suppose you have a random forest model with two hyperparameters: estimated number of trees and max depth, maximum depth of each tree. You can use grid search CV to search for the best combination of these hyperparameters by defining a grid of values, e.g. estimated 50, 100, 200, max depth 5, 10, 15. The model is trained and evaluated on all 9 possible combinations 3 by 3. A technique in scikit-learn's model selection module that randomly samples different hyperparameter combinations for a model. It's more efficient than grid search CV for models with a large number of hyperparameters. Tuning the hyperparameters of a deep neural network for image recognition. Finding the optimal hyperparameters for a gradient boosting model for time series forecasting. Imagine you have a complex model with 5 hyperparameters. Randomized search CV would randomly sample a set of hyperparameter values from a distribution, e.g. uniform distribution, instead of evaluating all possible combinations. This significantly reduces the time required for hyperparameter tuning, especially for models with many hyperparameters.